So we've been doing some radicals where you just have a radical and you can just get rid of it completely. But you'll notice in this one that we actually have two radicals. All right, we have two radicals. The goal of these is to get radicals on each side. So if I have a radical over here, I want to actually put a radical over there. I don't want two radicals on the same side. You could try it, but it makes your life a little more difficult, right? And sometimes when you have a radical equals a radical, then they both go away and you have a really easy problem. And so my first goal here is to just get the radicals separated. Have one on one side and one on the other. All right? This is only if they are different radicals. So you'll notice I have an x plus 33 and an x. I don't want those on the same side. They can't combine. If they have the same radicand or the same number underneath it, then of course I could just combine them into one using their coefficients, right? But I can't do that here because they're different radicands. So if they're different radicands, it's easier to separate them. So I'm going to move this square root of x over here with just a plus. It's plus square root of x plus square root of x, all right? So on the left-hand side, I have x plus 33. And on the right-hand side, I have 3 plus the square root of x, all right? Now, what is my index here? What's my index of this guy? 2. So I need to raise both sides to the second power. All right? The left-hand side's really easy. On the left, it's going to go away. But on the right, I need to FOIL it. All right? It doesn't just square the 3 and square the square root. This right here, this is the number one mistake I get anytime I have a group squared. When you have a group squared, it means the whole group times the whole group, okay? It does not just mean square the first guy and square the second guy. That's not how you do this, okay? So you have to actually FOIL it. On the right-hand side, you're going to get 3 times 3 is 9, 3 times square root of x, x times square root of 3. I said that backwards. And then you are going to get square root of x times square root of x, which is just x, okay? Everybody see that? So you have to FOIL it, all right? So you can simplify it. We have this right here that's going to simplify. And here's the thing. I do want to move over my 9 and my x because I really need now my roots by themselves, okay? So over here on this side, I'm going to add 3 and 3. I will have 6 square root of x, all right? For the other pieces, I'm going to subtract the 9 over, and I'm going to subtract the x over. Okay. They both cancel here. Over here, my x's actually cancel, which is nice, right? And then I have 33 minus 9, which gives me 24. And now I have an actually rather simple equation to solve. Get rid of that 6. How do I get rid of the 6? Yeah, I'm just going to divide both of those, right? And so I have 4 equals the square root of x. How do I get rid of that root? Yeah, just square both sides. So I have 16 equals x, all right? Now, you do want to check it. You do want to plug it back in and say, does this work? So if I check it up here, then I would get the square root of 16 plus 33 minus the square root of 16 equals 3. 16 plus 33 is 49, so that is 7 minus 4 equals 3. Yep, that's the solution. All right, so separate your radicals if they are not like. If they're alike, then you do want to get them on the same side and you want to combine them, right? But if they're not alike, you want to separate them and square to get them out. And sometimes, just like this, you're going to have to square twice to get rid of the radical. So on that first example, my x's really canceled out the first time. There are going to be times when it's going to go to a quadratic. So if we look at this, if we move my 10 over, I would have x minus 10 equals negative 3 square root of x, right? And then I really need to get rid of that root. I could divide by negative 3, but then I'm going to have fractions. So I'm actually not going to divide by negative 3 here. I'm actually just going to square both sides and let it work itself out. And so I'm going to go ahead and square both of these. This right here, if I square it, is foiling. So once again, if you have x minus 10 squared, it looks like that. So you end up with x squared minus 20x plus 100 over here. All right, you have to FOIL it. On the right-hand side, I have to square both of these. So negative 3 when I square it is 9. When I square the square root, I get x. All right? So when you have a quadratic, by quadratic I mean you have an x squared, you have to go back to your methods for solving a quadratic. All right? You can solve by factoring. You can solve by quadratic formula if you can't factor it, okay? And so in order to do either of those, it has to be equal to 0. And so if I have something like this, I'm actually going to move this 9x over. And I'm going to have x squared minus 29x plus 100 equals 0, okay? So now I'm looking for factors of 100 that add up to 29. So hopefully you can come up with that one. 25 and 4, right? 25 and 4 multiply to give me 100 and add to give me 29. So I would say x minus 25, x minus 4 equals 0. Remember, when you have a quadratic, once you have those factors, you set each factor equal to 0. All right, so I'm going to take the x minus 25 and set it equal to 0. And then I am going to take the x minus 4 and set it equal to 0. So my two potential answers are 25 and 4. Here's the thing. Anytime you have a quadratic, you definitely want to check to see if they work. All right? So I'm going to go back up here to my original, and I'm going to plug these in. So I have x, that's going to be 25, equals 10 minus 3 square root of x, which is 25. I'm going to check him. Then I have 4 equals 10 minus 3 square root of 4. All right? So I have 25 equals 10 minus 3 times 5. Does 25 equal 10 minus 15? No, it does not. That does not work. 4 equals 10 minus 3 times 2. Is that true? 10 minus 6. All right, so that works. 25 did not work. So 25 is extraneous solution. That is an extraneous solution. My only solution is x equals 4. 25 did not work. 25 did not work. Example 3. All right, so you have something raised to the 2/5. It's already by itself, by the way. So if you have a parentheses to a power, you want to get it by itself, or like the next example, one on each side. Your goal here is, like we talked about yesterday, you need to get it to a 1. How do you get a fraction to a 1? You multiply by the reciprocal. All right? So think about exponents. The way to multiply exponents is power to a power. So I'm actually going to take this and I am going to raise both sides to the reciprocal of this power. The reciprocal of 2/5 is 5/2. So I'm going to raise both of these to the 5/2. So here I have 2/5 times 5/2. That is just 1. So I have actually gotten rid of my exponent here. I just have the a plus 7. And on the right, I have 4 to the 5/2. So 4 to the 5/2, we're going to actually rewrite that as a radical so it makes a little more sense. We have a plus 7 over here. This is my index of my radical. So that means it is the square root of 4. And that is the exponent raised to the 5th power. What is the square root of 4? To the 5th power. What is that to the 5th power?
25.
So 2 to the 5th power, that's just going to be 2 times 2 times 2 times 2 times 2, right? That's 32. So now I have a rather easy equation to solve. How do I solve this? Right. And so my answer here, my answer is going to be 25, right? Here's...
That's where I got mixed up. I'll say the answer.
All right, so here's the thing. At this point, I still have a radical involved, all right? I still have a radical involved. And so when I have a radical to the 5th power with a variable involved, in this situation, you probably want to consider the negative possibility here. Because you have, in the parentheses, you have a variable raised to the power. So remember when I said when you're checking it, they're all numbers. There's no variable involved. You don't consider the positive and negative root, okay? But in this case, I still have a variable involved here. So yes, the square root of 4 could be 2, right? 4 to the 2/5 could be positive 32. But 4 to the 2/5 could also be negative 32. Because if I were to take, considering the fact that there is a variable involved here, I could also say, well, negative 2 to the 5th. And that would be negative 32. Okay? So when you still have a variable involved and you solve for this, you do have to consider a positive and negative root. Now, it would not have mattered if it had been to an even power. But because it was to the 5th power, a negative to the 5th power would be a negative. So not only is this answer potentially 25, I need to see what would happen if I had a plus 7 equals negative 32. That would give me a potential of, when I subtract that over, 39. So I could have two answers here. I could have 25 and 39 as my answers, negative 39. And so you do need to go back in and see if those work, okay? So I'm going to check my answers and I'm going to say, well, I have A as 25, 25 plus 7 raised to the 2/5 equals 4, okay? That's 32 to the 2/5. The 5th root of 32 is 2. 2 squared is 4. That one works. So 25 is going to be an answer. Check the other one. So I have negative 39 plus 7 raised to the 2/5 equals 4. Well, negative 39 plus 7 is negative 32 to the 2/5. The 5th root of negative 32 is negative 2. Squared is 4. Negative 39 actually works as well. Those are both answers that work for that problem. They both work for that problem. So for this one, we have decimals. Now, I do it a little bit differently than the book, just because it's not as intuitive with decimals. If you just absolutely love decimals and you can just see it right away, leave it as a decimal, I don't care. But I personally change my decimals to fractions because it's easier to see than what you need to raise to the power. All right, so I have this to the 0.25. 0.25 is a fraction. Hopefully all of you know 0.25 is a fraction is 1/4, right? And then on this other side, I have 0.5. That's 1/2, all right? My goal is to get rid of those fractions. In order to get rid of fractional exponents, you have to raise it to a power that will cancel it out, all right? So when I have two different denominators, the way I do that is I raise both sides to the common denominator. What's the common denominator between 4 and 2? Yeah, so I'm going to say 4 on this side and 4 on this side. You have to do the same thing, right? Will that get rid of my denominators? Yes, it will. So I'm going to take this left side, and I have 1/4 times 4. That's just the first power. 1/4 times 4 is just 1. So on this left side, I have 4x plus 5. On the right side, I have 1/2 times 4. That is just 2. So I have 3x plus 2 squared. Both of those now no longer have a decimal or fraction exponent. And so now I can just solve. This guy is as simple as he can get right now. This one you FOIL. Remember, that is going to be foiling this out. So I end up with 9x squared plus 12x plus 4. I have a quadratic, which means I need to get it equal to 0, and then I need to factor. So I'm going to first get this equal to 0. I have 9x squared minus 8x plus 1. All right, and that equals 0. And now I want to factor, okay? If you cannot go straight to the factoring, then you are welcome to multiply across like we've done in the past. 9 times 1, factors of 9, add up to give you a -8. So we have 1 and 9 pretty much. Does anybody need to see the factoring? Okay. So we have a +9, a -1. We're going to rewrite this. 9x squared plus 9x minus 1x minus 1. Factor by grouping. If you group behind a negative, you change it. Factor out that 9x, you get x plus 1. Factor out a 1, you get x plus 1. So you end up with 9x minus 1 and x plus 1. All right, so that's my factoring right there. I can just set these equal to 0. So I can set that equal to 0. I can set this equal to 0. And I'm going to get that x equals 1/9 or -1, okay? I have to check them. Like, I can't just assume that that's going to work. I have to plug those back in. And by the way, when I plug them back in, I actually plug them back in using my fractional exponents because that's the 4th root and the square root, okay? And so that's easier for me than doing decimal exponents. Like 4th root makes more sense than 0.25. When you plug these back in, the -1 actually does not work. So you have an extraneous solution with that, and this is your only answer when you check it.